Sorry, I actually hit the stop button on that last video, so I'm going to have to continue with that. But if we put this rock over here on this side instead, it's going to cause it to rotate counterclockwise. Now, if this rock were placed here versus, say, here, or let's just say compare this location on the meter stick versus that same rock placed here. Okay, so these two rocks are the same rock. This one is going to cause more torque than this one. Any weight on this side is going to cause counterclockwise rotation. Any weight on this side is going to cause clockwise rotation. And they kind of cancel each other out. Okay, so that's the thinking as we go into this concept builder here. Okay, so I'm going to do some of this kind of with you. Okay, so all the link will be on this assignment. Type in your name here as we always do, and there's 4 levels, and I went through all this really quick. Each level only has 3 questions. Okay, so we'll do one of these on each. So begin on the ground floor. Okay, so you have a fulcrum, you have a meter stick. All it's asking is which way is this going to cause it to rotate. Okay, this weight's over here. It's going to cause a torque in this direction. This force is pulling this downward. That force is acting some distance away, in this case 40 centimeters away, so we're going to put counterclockwise. Check your answer, and we get move on to the next one. Really, like I said, really simple stuff. Now if you weight on the other side, only 10 centimeters away, not as much torque, but it's still going to cause rotation. This is going to be clockwise rotation. And move on right to the next one. Again, bigger weight. Still on the right side, this is going to cause clockwise rotate. The whole thing's going to rotate kind of, the right side is going to be moving downward, the left side is going to be moving upward. So again, clockwise, check answer, boom. Super easy stuff. We finish ground floor. Then up we go to apprentice. Now we have 2 weights. This is where we have to think a little bit more. Okay, 2 equal weights on opposite sides. So the fact that they're equal weights is important. This weight is 45 centimeters away from the fulcrum, so you'd say that the force is 2 and the lever arm is 45. Here the weight is 2, but the lever arm is 40. So 2 times 40 on this side, 2 times 45 on this side. Now remember, it's 45 because we're talking about distance from the axis, and this fulcrum here is the axis that this meter stick is going to be spinning on. So this is going to be counterclockwise. This has just a little bit more torque on this side. These 2 torques are in opposition to each other, but this one's going to win. So it's going to go counterclockwise. It's going to win because it has just a little bit more lever arm. And check our answer there. Same kind of deal. Okay, 2 equal weights. All right, now how far is this one away from the axis? This is 40 centimeters away from the axis. This one's at 90 centimeter marks. This one's only 40 centimeters away from the axis too. So you have 2 equal torques, 2 equal forces that are both acting an equal distance away from the axis. And they're going to be working in opposition to each other. So this one is actually going to be balanced. Balance is another way of saying no rotation. Okay. Now, I'm not going to do quite all of these for you, but you get the idea. We're going to move on to the next level, and you can finish this on your own. So let's just go back to the main thing here. Do an example of master. We've already done the example of the first 2 levels. So which way will it rotate now? Okay, now we have 2 unequal weights. 2 unequal weights. Now this is where it gets a little tricky. Okay, you have a weight of 2 on this side, and it's 15 centimeters away. So it's going to be like 2 times 15 in the clockwise direction. 2 times 15 is 30, right? And over here, it's 1 times the distance it is away. So 1 times 10, 20, 30, 40, 1 times 40 versus 2 times 15. So that, doing the math in my head here, that makes me say we have 40 units of torque going in the counterclockwise direction, only 30 going in the clockwise direction. So which one's going to win? The counterclockwise one is, right? So we check that one. Again, you have double check counterclockwise and clockwise gets screwy in people's heads sometimes. So counterclockwise is going to win. And check that answer. Got the old data away there, as we always like to see that. And do one more example here on this medium level. Same deal. So you have 2 acting 15 centimeters away. So 2 times 15 is the amount of torque we have going in the counterclockwise direction versus 1 times 30. So 2 times 15 going counterclockwise, 1 times 30 in the clockwise direction. So 30 units of torque in the clockwise, 30 units of torque in the counterclockwise. Sounds like they're going to balance. Balance means no rotation. So you have 2 unequal masses balancing on either side of this. So hit no rotation and check our answer. And we're all set to go. Okay, again, I'm not going to quite do all of them for you here. And just maybe try a sample on the wizard level. So we've already done samples on the ground floor, apprentice, master. Let's see what they have for us at the wizard level. Same deal, but with just trickier numbers, I guess. Okay, so we have 8, a weight of 8 on one side, so 8, and it's 10 centimeters away. So 8 times 10 is 80, so you have 80 units of torque going in the counterclockwise direction versus 4 times 10, 20, 30 times 30 centimeters as the lever arm here. So this sounds like 4 times 30 versus 8 times 10. 8 times 10 is 80. 4 times 30 is 120. So which one's going to win? The clockwise direction is going to win, right? So check that. Check our answer. Continue. Do one more, and then we'll be all done. Okay, so we have 4 on this side. 4 is 40 centimeters away from the axis. So 4 times 40 is 160, right? Versus on the other side, 8 times, we're only 20 centimeters away from the axis on this side. Only 20 centimeters away from the axis on this side. So 8 times 20 is 160. 4 times 40 is 160. So 160 going in the counterclockwise direction and 160 going in the clockwise direction. Those two things sound like they're equal and opposite. So that means no rotation. Check that answer. We got our data away. Okay. Now I've done most of this with you or for you, but you still need to do it on your own. You want to see all 4 trophies. Okay. A good little practice for torque and balancing. Okay. This whole chapter is just about torque, how things rotate, balancing. Eventually we'll talk about center of gravity. And do some kind of neat examples there. Another lesson I wish I could teach you all in person because there's some cool demonstrations to do and all kinds of stuff. But it looks like we're doing this distance learning indefinitely now. So here's the new normal. I guess I was maybe assigning a little bit too much work before we got to spring break. So I'm going to chill out a little bit on that just so everybody feels comfortable and has enough time to learn what's going on. But I don't think this assignment should be too taxing for you. So again, watch these 2 videos. It's just one video kind of split into 2, I guess. And then do all 4 trophies on that concept builder. And again, I already did a lot of that for you, so you're just going to be kind of redoing exactly what I did, okay? And make sure you attach a picture of that to when you turn in the assignment. On that, I hope everybody's doing all right. And thanks, guys. And as always, either comment or email me if you have any questions or problems.